It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about continuity of a function at a number with a given piecewise function. Let's start off with determining if the function is continuous at the given number c for f of x equal to -1 if our x is less than or equal to 2, and x minus 3 if x is greater than 2. Notice that we have a specific domain here because we define our piecewise function as a function composed of two or more functions with a specific domain. Our c here, we are trying to test whether our function is continuous at the number c, which is equal to 2. So the first thing to do is we are going to test our function whether it will be satisfying all the three here. First, that f of c must exist, meaning once we try to plug in our c value on our f of x, automatic will be getting a number, a value there that will be existing. But if you are getting a value of f of c which is gonna be undefined, indeterminate, and an imaginary number, automatic our f of c doesn't exist. So if your f of c doesn't exist, you are not going to go through with testing out the second condition, because automatic, if your f of c doesn't exist, that means your function is not continuous. There is discontinuity of your function. So let's try to test it out. Let's have our f of c, or this is what we're having as f of 2. F of 2 would mean we are going to replace all the x's here by the value 2. So let's try to check. For a piecewise function, you are not going to make use of all the functions here, but you are going to simply spot or determine what will be the function that you are going to use among those functions within the piecewise function. Now, how to check? You are going to look at the domain here, and you are going to check where does your 2 belong to. Now, if you're having trouble with this symbol here, understanding the symbol here, so all you have to do is to think about a number line. You can try to draw a number line. This might be helping you a lot. And then plot the critical value here. We can call it a critical value or the basis value here, which is our 2. We can plot it out and then know what are the numbers that are located on that particular direction. So if you've noticed this symbol here, this symbol is a less than or equal to symbol. If you try to look at the symbol, the pointer there, or the tail part of the symbol, is pointing towards the left side. So automatic left side of 2, or the values on the left side of 2 are gonna be the values that are part of the domain of that particular function. What are those numbers? Those are 1, 0, including all the numbers that are in between those values of 1 and 2, and 0 and 1, and so on. Now, we are to check whether our 2 there satisfies the domain of that particular function. Take note, we've got an equal symbol here, so meaning to say, if you are to plot your number line, the 2 there, and the less than symbol, that means to say that this one is a closed graph, and the values are gonna be located on the left side of that particular value. So since this is closed, meaning to say, we are going to include that number as part of the domain. So since we are looking for f of 2, we are going to choose this function here because we've satisfied the domain there that x is less than or equal to 2. So using that one, we have our f of x is equal to -1. So therefore, f of 2 here is equal to a negative 1. So no matter what the value of your x there, this is actually constant function in which no matter what value of your x there, your y will always be equal to a 1. So that is the value of f of 2. f of 2 is negative 1. So since we have a negative 1 value, that means to say that our f of c exists. So since f of c exists, this might be continuous or not. We are going to check out the second condition in which our limit of f of x as your x approaches c exists. So let's try to check. Now, since this is a piecewise function, we have here a left-hand limit and a right-hand limit, because most of the piecewise function, I said most of the piecewise function, they may be different in values from the left hand and the right hand. So that's why we have to check on the one-sided limit of the piecewise function, the left-hand limit and the right-hand limit. If the left-hand limit and the right-hand limit are equal, then that means our limit there exists. So let's try to check out our limit of the f of x as our x approaches our c, which is 2, coming from the left side. So coming from the left side, we're checking out the left-hand limit. So our limit of f of x, we don't know yet the f of x here. That is why you are to determine what particular function are we using to satisfy that the values there are approaching your 2 coming from the left side. So if you notice on the first condition, we plotted the number line there and we have our 2 here and the values to the left of that will be satisfying the first function. Meaning to say, we are going to utilize the first function there because the values there are moving from the left side, moving towards the 2 or approaching towards 2. So we will be utilizing our function f of x equal to negative 1. So again, we will be using the limit of negative 1 as your x approaches 2 coming from the left side. That will be equal to limit of a constant. That's always a constant, so we have that as negative 1. We have our left-hand limit as negative 1. We are now ready to check our right-hand limit. So let's have our limit of f of x as x approaches 2 coming from the right side. So again, we are to check what function are we utilizing here in which it would somehow satisfy that the values are coming from the right side of 2. So checking up on the first function, we've got these domains, the values are coming from the left side of 2. So that makes it not satisfying function 1. We will not be utilizing function 1. So let's try to check out function 2. On function 2, we have our number line here, and we have the number 2 as a basis. Notice that your symbol is greater than. The tail part of the greater than symbol is pointing towards the right side. So meaning to say, what we are considering here are the values on the right side of 2, which are 3, 4, 5, but never including the value 2 because that doesn't contain an equal symbol. That means to say that 2 is not part of our values of your x or the domain. But take note, in between this one, we still have a 2.01, 2.1, 2.2, 2.3, and so on. These values are part of our domain. Now, checking up, going back, our values here, our limit that we wanted to check are the limit on, or is the limit on the right hand. We are considering values that are approaching to 2 coming from the right side, in which that satisfies the second domain. So we will be utilizing in our limit on the right hand our limit of x minus 3 as your x approaches 2 coming from the right side. So since this is a linear function, we are going to simply plug in the value 2. So we have here 2 minus 3. This is equal to negative 1. So comparing the left-hand limit and the right-hand limit, since the two are equal, therefore, our limit of our f of x as your x approaches 2 on both sides, that will be equal to a negative 1. There exists a limit, so there's a bigger chance that this will be continuous. But then, we still have condition 3. We need to satisfy the condition 3 in which limit of f of x as your x approaches c must be equal to f of c. Identifying the limit here of f of x as x approaches to 2, we have that one as negative 1, and we have f of c here as negative 1. Comparing the two, they are both the same, they are equal, so that means we can conclude here that our f of x is continuous because all three conditions are met, is continuous at c equal to 2. So that is how we determine our continuity on a piecewise function.